Hi, I'm Naz. I'm the CEO and founder of Rebel, and the author of Developed Life and maintainer of the Rebel 2 crate. I believe that open source comes from an open heart and from the joy of coding. In today's video, we're going to do a deep dive of the Rust condition variable. So this is actually a fantastic synchronization primitive that prevents the use or prevents the need to have busy waiting. And the use case for this is where you have more than one thread. One thread is a worker. It's going to take some time, some unknown amount of time to do some work. And the other thread is waiting on this worker thread. So you have a worker thread and you have a consumer thread. So um, typically the consumer thread could just pull some shared data, shared memory, to see if the work is done yet. And if it isn't, it can just wait in a while loop. And so that's lossy. Lots of CPU cycles are getting burned. Or we can use something like a spin lock. But condition variables are like the most efficient way to do this. And they kind of so they provide a signaling mechanism between these two threads. So the consumer thread can wait on the condition variable, and the worker thread, when it's done, can signal notify all the blocked threads that called wait, and then resume them, so unblock them, so then they can continue and do something with the work that's produced. So there's this dance that goes on between these two threads. There's a wait and notify, and you can either notify a single thread or many threads. So it's notify or notify all. And this is reminiscent of Java, wait and notify, where there's a similar kind of thing where there's a synchronization keyword and a wait and notify methods on the object class itself. So, and that Java's implementation of that is this monitor primitive, which is different than a semaphore, which is a mutex. So this monitor primitive or synchronization mechanism has the data that's shared along with the mutex and this condition variable, all like put together in one clump. And so the condition variable in Rust Condvar is the signaling mechanism. It's not the mutex or the data, or even the mechanism to share it between threads. And Rust has some really awesome. The implementation of Condvars is awesome because Rust and the type system and ownership actually ends up eliminating the need for runtime checks like what Java does. So I will actually, in this live coding video, I will actually work through an example where we have two threads and we have a worker and a consumer thread, and actually build out the monitor using condition variables, and we'll see it in practice. Okay, so let us open a terminal and let's see, go. Okay, let's see, this should, let me see what the second, oops, let's see, okay, so we have, I think we're good. Okay. Okay. Yeah, I think we're good. All right. So the first thing we're going to do is handle the imports. So we have sync. So the Arc Mutex and Condvar, they go hand in hand. and we're going to see how that plays out in this live coding video. And there we go. And then I think I want, see, what is this? Let's disable all these linters. So we want, let's see, what does it say? Unused import. So unused imports, let's see. Oh, that got rid of almost all of them. I think this is just a spelling mistake. So C spell words. Is that right? Oh, I can never remember what the, I think it's C spell words. Condvar. There we go. All right. That just disables the spell checker. I mean, not doesn't disable the spell checker. It allows this as a valid spelling. Okay. So now that this is done, let us so first thing we have to do is consider with the struct inside inside of which this condition variable goes. So we're going to call that a StateMonitor, and the StateMonitor is going to have, that's actually, this is right. Okay. So it has a value which is protected by mutex because thread safety. And we have the condition variable. So that is the sort of foundational monitor. So this now in our, actually we can do one more thing. Let's do this safe state monitor T. We're just saying that we want to take the, oh, actually this is a lot of dead code. So we're going to take the StateMonitor struct, wrapped it in an arc, so we can safely send it between threads, because we're going to have two threads. And that's a good starting point. So actually for T, we're just going to make this a number. So in our example, we'll just do something like this. We'll start with this data being 0. The worker thread will take some time to do something and change that value to something that's non-zero. And if it's 0, it means no work has been done. If it's more than 0, that means work is done. And then that'll be our, kind of like made up example, because we're not really focusing on the task that the worker thread has to do. We're more concerned about the mechanism, the signaling mechanism, and the monitor struct, and passing that monitor between threads. So, okay. So now we will step out a few things. So we need our StateMonitor instance. So that's not right. So it's StateMonitor. That's, yeah. So what we're going to do is that our data is just going to be like a number. And so when, let's see, when we're just going to make it so that this is, yeah, so we're going to make the state just hold the number, that when the worker thread does something, it'll make this number like 10 or something. And so that's how we know some work has been done, because the state has changed. Then in order to be able to pass this around between threads, we need to wrap it in an arc. So that's done. Then we're going to spawn a worker thread to some work. Then we're going to spawn oh, actually, to do some work, update state, notify threads or block threads. And here we're gonna block main thread until the worker thread is done. So there you go. There we've stubbed out sort of the structure. So here's the spawned thread entry point, which is just going to be one of these. And then it's basically the same for the main thread entry point. I mean, same in the sense that they take the same argument. And then here we're going to thread spawn. What is this? Thread spawn. Actually, does it move? Or and then here we need to clone this thing. So we're going to do a save state monitor move, and then we're just gonna spawn a thread and call the thread entry point, and this is gonna go do some work and notify any blocked threads. And this one is just simply going to main thread entry point. There you go. So here, now that that boilerplate is done, actually we're going to do nothing with this, so we don't care about the joint handle. So we're just going to drop that. Okay, so far so good. Now we need, so this is going to be the worker thread that will do something, lock the mutex, and then put a value in it, and then notify any block threads. That's the job contract of this spawn thread. And then we'll do this equivalent for main thread. But let us do something real quick, which is we'll make a console module for just pretty print. So we'll do this. Actually, I think we can put the wildcard imports here. So here we can say 2 enums. We're going to say, I think it's like thread label. Let's do main thread, worker thread, and then we need a log function. So we'll say thread label, and here I think we can say thread label will be, so we're going to colorize. So for this, I'm going to cargo add rebel TUI so that we have nice formatting and stuff. So here we can say FG color, wait, what is it? FG, I think lizard green. So this is for Porsche fans out there, this is a color inspired by lizard green Porsche color. And then we can have another one that is FG frozen blue, which is I think another Porsche color, if I'm not mistaken. And then finally, we can just print line this. There you go. And so now it's just a little nicety. And then another thing I'm using is the Rebel extensions. So you can see it here. So I have Rebel theme and which is part of the Rebel development pack for Rust. And it also comes with the theme has got really nice syntax highlighting for Rust, and it adds folding regions for Rust. So for example, I can fold all my use statements, or I can fold, this console, and it works better than the default folding region support that comes out of the box with VS Code because it's specifics for Rust. Okay, so now that that's done, let us implement the spawned the spawn thread logic. So here we're going to just say log. Oh, actually, we could say use console, all the console thingies. So here we could say thread label looker, and we are started. Perfect. Then we can do, let's see. So now let's say we're going to do some work, and it's going to take some time. So I'm just going to do a thread sleep. So let's just say it's going to take 2 seconds, right? This is simulate something like that. And now that through this computation, I have, come up with a new value, I need to put this value in the state. Update value in state. So in order to do that, I need to get access to the 2 fields inside of this argument. So in order to do that, I'm going to destructure this thing. So we're going to do save. So that's dereferencing the arc to get what's inside of it. And then we can just say let, I think it's StateMonitor. There you go. That's it. And so we just essentially get these fields out of that argument. And then here, what we're going to do is get a mutable a guard for the value that's inside the mutex. So we're going to say value lock unwrap. So now, because it's mutable, I can put stuff in it. And so what I'm going to do is I'm going to say, like take the existing value, and I am going to do a saturating add of 10 or whatever, 10, let's say. It doesn't really matter. So I lock it, update the value, drop the lock. So I am done with updating the state. So if I leave it like this, any of the threads that are waiting, they don't know. That's where this comes in. Notify that state is updated. And here we can say Condvar, oops, notify just one thread. That's why I'm just saying. And finally, we can say thread label worker. Yep, definitely it's done. So we can say here, let's see, signal other thread to unblock. And here we can put a log message. We can say updated state. We did update state, so we updated state to what did you update state to? Just value guard. There you go. So whatever the new value guard, and so we wait, update the value, and then notify any block threads. So that's this updated state, and you can say worker is complete. and signal other thread to unblock. Perfect. Actually, we can just say, work is complete. Complete. Okay. And then, so that takes care of the worker side. Now let's look at the main thread, which is the thing that's blocked. So we're going to do exactly the same thing with regards to the state monitor. Destructure it, get the value in the mutex, get the mutex and the Condvar out of it. So here, we need to check to see if the work is done or not. And in order to do that, we need to peek inside of the state monitor and lock the value, read it, and then unlock it. So, so let's do that. So let's do select value guard is value dot wrap unlock, right? Notice this is not mutable. So this is not mutable. Whereas this is mutable. Where did it go? This one. So, okay. So now what we can do is that we need to essentially put this in a while loop where we check to see is it done? If not, then wait. And once we wait, we're blocked. We're not gonna keep doing this again until we get notified. So let's we could write this while loop ourselves, but there's this wonderful method called wait while, which is literally made for this. So we're just gonna do Condvar, and notice I'm accessing both the fields. I need both. So I'm going to do wait while value guard, and it's saying some sort of condition. What is this condition? So if the condition, if it is not met, return true. Okay, so this will wait for the next notification and check again. It repeats until condition is false. Okay, so here, if it is, oops, what is this? What just happened? So if it is 0, that means we're not done. So now something interesting happens. And I've left this dangling like this on purpose because I wanted to show you something. So what if we did something like this, where after, this wait while thing, we want to check what is the value. Look at this. Borrow of moved value. What does that mean? Look at this wait while. The wait while function, it consumes the guard. So it owns it, right? This is not a reference. This moves it. So the reason for that, this is why Rust with its type safety, type state, it can prevent this some kind of exception. Yeah, no, not this one. There's some other exception, I forget, which can happen in Java. Actually, I had in my notes. Let me see what this is. I think it was. Oh no. I think I may have lost my notes. But anyway, so there was some kind of exception that happens where if you don't do a wait, but you call a notify or something like that. So in Rust, you can't do that because the guard that you have is gone when you call wait while. And why is this? This is super important. So if this guard wasn't consumed, moved and dropped, then while the waiting is happening, the worker thread, it will not be able to do this, right? Because remember, it's going to take some time to do something, and then it's going to update the lock the mutex and update the value. If this thread is holding on to this lock because it's a mutex, not going to happen. So it's super important that this consumes that guard and drops it. So while it's waiting, the worker thread is able to lock the mutex and update the value. So this is amazing. So what happens? Like, but I, now I let's say that I know that the condition, it's not 0, but what is it? How do I access it? I can't access it with value guard. Well, Rust has it covered. So this is the new value guard. And what this does is that the so the new value guard, it's the new mutex. So oops. So when this is ready to return, it gets a different mutex guard on the mutex and returns it, which we can use. So this is super handy. So we end up with a different value guard than when we went in. However, with this value guard, just you can access the value. So we can say log, let's see, thread label main. Let's see, we can say format something like, let's see, value guard, new value guard. And we can say unblocked, work is complete, and the value is this, something like that, right? So let's see, what is the problem? Oh, doesn't implement display. Wait, what? What's going on? Oh, right, because that's a result. So I'm gonna call unwrap here. I mean, we should do this, but this is like not production code, so we would not use unwrap in production code, but here we can. Okay, so there you go. This is a new value guard, and here we can do something like this. So here the block actually, the block happens here. So we can say blocking until let's see, block for work to complete worker thread, something like that. Okay, yeah, this is the thing that I really wanted to spend some time on because I think this is super important. So here we could say, let's see, value guard. So this one, I think it need a comment here. This is like consume the guard, drop the lock. So worker thread can put stuff in the value. And this condition is something along the lines of not met means not met is true. Something like that. And we have to evaluate, by evaluate, I mean, we have to look at the value and do an assessment on it, run some logic to figure out, whether the condition is met or not. That's not part of Condvar. That's on us to do in this in this closure. So in this closure, this is the closure to assess completion or something. Yeah, or completion, condition, whatever you want to call it, like condition. So the condition is derived from the state, right? It's if that makes sense, and that's where actually it's not it. It's whatever the value, right? There we go. So let's see. That is written. Moment of truth. Let's see if it runs. Okay, worker starting. Oh, here we go, main. So look at the sequence of logs. So right away, the new thread is spawned, the worker thread is spawned. But it's take a bit of time. And so this actually runs first. And what the main thread will do is immediately get blocked right there. It's it uses the Condvar to get blocked because it's, remember now, it's for 2 seconds. So while it's blocked, no CPU resources are being used. Then we can see almost immediately the worker thread is because it got spawned. It starts up and then it sleeps for 2 seconds. Main is blocked, worker sleeping, wakes up, acquires the lock, updates the state, and signals to other thread to unblock. That unblocks the main thread, jumps out of here, gets a new value guard, because remember the old one was consumed and dropped, so that this could happen. And then finally, with this new value guard, we can see what the actual, or the new value is generated by the worker. And there you go. That's that's condition variables on monitors in action. So one thing I was mentioning was that Rebel, where is it? OpenVSX, this one. You can get those extensions I was talking about from here. They're also available for VS Code. You can get that from here as well. But yeah, check it out. I think you might like it. I use it every day, and if you have any feature requests, let me know. But yeah, there's a lot of really cool stuff in here for Rust development. So on that note, I think we are done with this live coding video. Thank you so much for watching. If you like this style of video, give it a thumbs up and subscribe. And yeah, I have a bunch of new content lined up. I've been taking a hiatus for a while, but I have a bunch of content I plan to publish over the coming weeks and months. Thank you again for watching, and have a great day.